So now we're going to talk about OR probabilities, and OR probabilities this time is going to use addition. And again, we have two different types. We have non-overlapping, which are also known as mutually exclusive, and we also have overlapping. The non-overlapping mutually exclusive ones are when events cannot occur at the same time. So they're really not anything special to talk about because it's essentially the probability, let's say, of if you're playing rock, paper, scissors, and what's the probability of getting rock or paper or scissors? So these are individually um, they're mutually exclusive from each other. You can't have them both, so they're non-overlapping events. So these things can't happen at the same time. Whereas with overlapping events, those are the ones that are much more familiar to us. So let's when we do overlapping events, the idea of having a Venn diagram is kind of a nice visual for us. So let's suppose that we want to find the probability of picking out a black card or a 7 card. So out of a deck of cards, so a black card or a 7. Unlike with the and probabilities, the word or always has to be written to indicate that it's an OR probability. Okay, so let's think about this back to our Venn diagram. So let's suppose that this circle is black and this circle is the 7s. And so we first remember working from the inside out. So how many black 7s do we have? There's 2 of those. And then there's a total of, so there's a total of 52 cards. Half of them are black, half of them are red. We have 7 for each with the 4 different I'm sorry, 4 7s with because of the 4 different suits. So if we've already used 2 black cards, that means there's 24 cards left in the black, just black. And if we've already used 2 7s, that means there's 2 cards that are not black. So these again are, and I'll just say that these are our red ones. So we want to know what's the probability of a black card or a 7. So we have 26 black cards or a 7. We have 4 7s, but we overlapped or double counted this 2. So we could think of this in 2 different ways. We could say that there are 26 out of 52. And again, OR probabilities are addition plus. Well, we have 4 out of 52 7s, but we double counted, so we have to subtract out the 2 out of 52. So that's one way of thinking about it. Or in this case, we can simply add the 24 plus the 2 plus the 2 out of 52. Now we're not double counting the 2 black 7s here. Okay, so either way we can look at using, if you look up a definition of OR probabilities, it gives you something similar to this. But if we use the Venn diagram, because our Venn diagram is helpful in this case, we can just look at adding each one of those regions in this area. Let's look at another example where we have 20 English women. We have 25 English men. $25 American women and 20 American men. Okay, and so let's just fill in our Venn diagram. I'm going to just use the first idea here. So I'm going to call this my English. I'm going to call this my women. I could use any of those to figure out where my overlap is, but I'm going to use that one as the first one. So that's my first one. Now I have 25 English men. So that means I have 25 These are my English men. And then I have 25 American women. So this is the women. So they're not English, so that we're making these our American women. So these are the American women. And these are the English men. And then we have 20 American men, so we don't have any place to put them. So we're going to put them over here on the outside. So these are the American men. And so what is the probability? So we did each one of those. What's the probability of a woman, picking out a woman, or an American? Okay, so we have a total of 20 and 25 women. So we have 45 women over the total. And let's see, the total is 25 plus 25 plus 6 plus 20 plus 20. So we have 50, 90 people. Plus, because it's addition, how many Americans do we have? Well, we have 25 American women and 20 American men, but we've already counted this 25 Americans with our women category, so all we need is our 20 out of 90, which would end up with a total of 65 out of 90.